Lesson 18, calculating with units of measures. Okay, we're just going to start right with an example.
Okay.
If I want to convert 2,500 seconds to hours, I'm going to use unit multipliers. So if you do unit analysis, it really is helpful. So you start with 2,500 seconds. And I want to change that to hours. So first I'm going to change the seconds to minutes. So if you look at the units, I have to have the seconds in the denominator so I can cancel it out. And then you can put in your numbers. So 1 minute has 60 seconds. Then I'm going to convert minutes to hours. So the minutes label has to go in the denominator, hours in the numerator. So in 1 hour is 60 minutes. So now when I cancel my labels, this is called unit analysis. You're just looking at the labels and analyzing where everything needs to go so that you can end up with hours. Basically, you take 2,500 and divide by 3,600. So it is approximately 25/36 hours, or 0.7. So it's part of an hour. Not even
So
full.
all you have to do is make sure, like, if you have the label in the numerator, you have to make sure it's in the denominator.
So you can cancel. Yep. Or opposite, like vice versa.
Wait, isn't it closer to 1/7?
Like,
Wait, 25
okay. So we have to make sure that we are accurate, called accuracy. That just means that the measurement refers to how close it corresponds to the actual value. Then there's another word, precision. All of these are in your book and defined, so they're written in blue. The definition for precision is basically it refers to the number of significant digits that it contains. So we're going to go over real quick a reminder on significant digits. So there's a couple of rules here. You want to, first of all, count all non-zero digits. So the number 432.1 has 4 significant digits. You need to count the zeros between significant digits. I'm just going to do SD for significant digits. So if there's zeros between digits that are significant, you need to count them. So 5,003 and 200ths, we would count all of the digits including the zeros. So 4, 5, 6. So this has 6 significant digits. Tan?
So does that mean that 1,000 only has 1 significant digit?
Mm-hmm.
Almost 1,000.01.
Yeah, then it would have more.
There.
So leading,
0.01.
so 1,000. Only has 1 significant digit. Okay, leading zeros are not significant digits. So in this number, has 2 significant digits.
Are we talking about scientific notation as well? With, along with, does that go along with significant digits?
Yeah.
Yeah.
Mhm.
So could you have like 2 times 10 to the billion zillion power, and it would only have 1 significant digit?
0, say what?
If you do like 2 times 10 to the
Million.
bazillion power, or whatever.
2 times 10 to the bazillionth power only has 1 significant digit.
Yes.
Yes,
If you have,
that's
like,
true.
But if you did 1 point, like a gazillion zeros and then 1, that would have like a gazillion.
So then it would be a gazillion and 2 significant digits. Yes, Netta?
So with the 5,003 and 200s, you counted that 0 right after the decimal point as a significant digit, right?
Yes.
Yeah.
But in the other one, all those other zeros before the 32, you didn't count as significant digit.
That's because there's no significant.
There's not, yeah, this
Oh,
0
okay.
is between 2. These are not.
They're all between zeros? Okay.
Yeah. So you do have to count, this is really weird because you think you don't, but you do have to count trailing zeros after a decimal.
Yeah, that's
What?
the nearest one.
So zeros after
Isn't that like you?
a significant digit and a decimal number. And the reason is, if you write it with them, then it's meant to stay with it. So this has 4 significant
oh.
digits.
Why is that important? Why does it matter?
Some questions.
It's just because it's unusual. You wouldn't think that they would be significant because usually we drop the trailing zeros. But if they're written in the number, then it is.
So like if,
significant.
like in that round to the nearest 10 millionth or whatever,
Right,
is what it is.
right. Yeah, sometimes it'll say round to the nearest and you don't
Yeah,
get there, so you just
I
have to
get
put
it.
zeros to get
Like
there.
sometimes in our homework it says round to the nearest 10.
Round to the nearest tenth and
it's
then
like 3.99. So you just end up with
4.0. Right. Heidi,
Okay, so like for the second, like the middle one, if you were to put it was 1.32, then all of them would be.
Mhm. Yep. So there's some rules that we use with significant digits. So if you're adding or subtracting, the answer should have the same number of decimal places as the measurement with the fewest number of decimal places.
What?
Okay, so we'll write it and then I'll show you an example. The answer should have the same number of
Wait, so if you added 0.4 plus 0.6.
decimal
it'd be 1.4.
places as the measurement with the fewest number of decimal places. I don't remember in all of my college years paying much attention to this, but you guys will need to if you're asked to on the homework. So for instance, 36 and 56 thousandths plus 18 and 2/10. So when you add these, the answer should have the fewest number of decimal places as your add-in. So it needs 1 decimal place for your answer.
Wait,
So-
sorry, say that one more time.
So the fewest decimal places is 1. This one has 3 places, this has 1. So your answer should have 1
That's dumb.
decimal place. So we're just going to put it to 54.3.
But that's rounding.
So it's just as
That's the rule to rounding.
Well, that's a stupid rule.
Wait, let me just wrap my head around this one more time.
Okay.
Okay. So, smallest amount of decimal places should be how many you have in your answer.
Yes, that's if you're adding or subtracting.
So you're essentially just telling you to round.
What about multiplying or dividing?
It's the same thing except
Except.
Except it's not.
No, you're not looking at decimal places, you're looking at significant digits. So when you are multiplying two numbers, let's do 2.09 times 0.050. So this one has 3 significant digits. This one has 2 significant digits. So your answer should have 2 significant digits.
Wait.
So the answer has the same number of significant digits as
So
whichever fact.
significant. So it's number of decimal places, adding and subtracting and for multiplying and dividing. It's just whichever one has the least amount of.
The least, yep.
Okay.
So if I were to do 2 9/100 times 50 thousandths, I get 1045. So 1045 10,000ths. I need 2 significant digits. So I would round to the 100.
1.00. Oh.
So
Hey, that's the same as decimal this time.
0.10. Say what?
It's the exact same as the decimal though this time, as the.
Oh, yeah, it is. It
Wait,
turned
so
out that
how
way.
often will we have to apply this rule?
This much. Not very much. Okay, we're gonna do lesson practice